Hello, here we're going to look at 1.4, writing linear equations. Here's the why. Now that we can find a rate of change, we can find all the values along the way and before and after the two coordinate points that helped us find the rate of change. Examples of where we're going to need to write linear equations is city layouts. If you look at, this is a portion of New York, you see lots of streets and roads, and here's a highway winding through that as well. But lots and lots of lines, right? You see the different roads there. You see some other types of curvy roads in there as well. But the majority of these guys are straight lines, right? That are vocabulary words of parallel and perpendicular together. And we can use rates of change in writing linear equations to take a look at a pattern and make future estimations. We can take a look at a pattern and talk about where it would have been in the past. So writing linear equations allows us to take the data that we have and talk about a lot more than just the 2 points that we have and the 2 points that form the rate of change. Alright, so here what we're going to do is talk about parallel and perpendicular lines. What do they look like? Where are they used? So parallel lines are lines that never cross. Right? So what makes this true from mathematically is that they have the same slope but different starting point, or y-intercept, but they have the same slope but different starting point. So they are used for parallel roads, right? Roads that run the same direction, and a lot of times these will even be one-way streets. If you take a look at the United States in general and zoom out on Google Maps, you'll see that there's highways that run across, and for the most part our highways, now they squiggle more than this, but look something like this. We have a lot of highways that run left and right, and we have a lot of highways that run north and south. And they do squiggle, but for the most part we have parallel highways to every once in a while, every few hours, if you've gone on a long road trip, you hit another major highway that travels, north or south. Like, for example, to go through Atlanta, you can go through Tennessee through 65 south, or you can drive to Lexington and take the interstate south from there too, and go through either Knoxville or Nashville. So that's parallel lines. They're also used for lanes on the road. When you're driving somewhere, you have those little dots in the middle, and the lanes travel parallel to each other because we don't want them to cross, because that means that cars are going to crash. Now, perpendicular lines are lines that form a 90-degree angle. So they are used a lot in architecture as well. If you look at the corners of rooms, they make 90-degree angles. The ceilings, the ceiling tiles, the tiles on the floor, they all make 90-degree angles. What makes that true is they have opposite reciprocal slopes. So that's what's true about perpendicular lines, is they have opposite reciprocal slopes. So here's some of the things that we'll ultimately be able to do. We've got a city map here. The post office and city hall are marked on the coordinate plane. We're going to write the equation of the line in slope-intercept form that passes through these 2 points. And then we can do other things as well, such as add on other spots and maybe bring in perpendicular lines, because you'll see that on city grids they have parallel roads and perpendicular roads, making those 90-degree angles. So here's some of our definitions. This equation right here, y equals mx plus b, is called slope-intercept. And that's because the two values that it talks about is the m value, slope, and the b value, which is specifically the y-intercept. We will certainly use slope-intercept form to help us write equations. Now, there's another type of equations too called point slope. Now, what's useful about it is that it still talks about slope, but you do not need to know the y-intercept. You just need a y-coordinate and you need an x-coordinate from the same point. So we'll use a slope, and we'll also use a single coordinate point to write equations into point slope form. And that, once again, is handy because this equation, you need to know the y-intercept in order to write it. Point slope, you do not need a y-intercept. And that's what comes into play here. So it says, write the equation of the line given. It can come in many different forms. You know, sometimes like in that picture over here, we have 2 points and we need to make a line. Sometimes we might know a road's slope and its y-intercept, and we can write, you know, the line a little bit easier from that perspective. But what we're going to do here is talk about, you know, what information you're given, which form should you use. You want to use slope-intercept form if you are given a slope and you are given a y-intercept. If you're given both of those, it's very easy to write a line in a slope-intercept form. For this one, if all we're given is a slope and a point, and that point is not a y-intercept, you would want to use point slope form. Now, you might be wondering, how do I know if I'm given my y-intercept, Mr. Cottle? Well, they'll either tell you that it's the y-intercept, or also a y-intercept is always 0, a number. Anytime you have a 0 right there for the x-coordinate, that makes this point right here your y-intercept, but only when that 0 is there. So you must have a 0 for that y-coordinate to be your y-intercept. So that means if you're given any other point, such as any type of number here, that means you will want to use, right, except 0, so not 0, you will want to use point slope form. And we'll go through and get the practice on these, but this is the reasoning behind using the different points. Right? Another example of where we'll want to use point slope is if we are given 2 points. Right? 2 points, but no y-intercept. Because 2 points can tell us the slope. Up here, if we're given 2 points, we can find the slope. And if one of those points is your y-intercept, we would use slope-intercept form. So we have 2 different ways of doing it because sometimes we get different pieces of information. And one of the things that we'll be learning together is when to use each one and how to practice writing equations based upon pieces of information, and even taking down situations such as perpendicular and passes through.